Hi guys, today we're going to take a look at the Unit 1 Classwork packet, page 5. Once again, that's the Unit 1 Classwork packet, page 5. Now, our goal for today is to talk about something called segment addition, but before we can get to segment addition, we first need to talk a little bit about what a segment is, okay? This is actually a potential EOC question, by the way. There's going to be one or two questions on your exam that are pure definition based. So we know that a line, right, goes on forever in both directions. By contrast, a line segment, take a look at what I've done here. Do you guys see arrows on the ends? Nah, instead of arrows, you just see 2 points. So we would say that a line segment is the portion of a line that passes through 2 endpoints. Or we could say the portion of a line, better, let me say that better. The portion of a line between 2 endpoints. Let me say it a third time. A line segment is the portion of a line between 2 endpoints, okay? Now, looking at what's actually in your classwork packet, when we talk about distance and in this case length are actually going to be synonymous, meaning that they mean the same things, but there's actually something mathematically that we can do here. If we want to find the distance between A and B, we would write that as follows. Now, to understand what that means, we got to go back to Algebra 1. In Algebra 1, we relearned or applied something known as absolute value, right? Absolute value was a fancy way of saying, like, how far away something was from 0. But what I want you to remember about it is that it was positive. So if you take a look at the example that's in your packet, point B was at, I think it was 3 units, and point A was at -1. So in order to find the length of that segment, I would simply do the absolute value of 3 minus -1. Now be careful, of course, right? Recall that minus a minus is a plus. So 3 plus 1 is 4. And in this case, absolute value of 4 is 4. So for that particular problem, we would say that segment AB, by the way, segment AB, notice how when I draw the little thing, sorry for the lack of vocab, when I draw the little thing up top, it doesn't have arrows because it's a segment. I would say it has a length of 4. Now, when 2 segments have the same length, let me say that again. This is the second box that you're going to see on page 5. If 2 segments have the same length, right? Length, how long? Then the segments are congruent. And this is how we would write that. So I'm not going to waste my marker here drawing segment CD, but in the blank, here's what I want you guys to write. I want you to write that segment AB is, pay attention to this symbol because that's going to be really important, congruent to segment CD. I'm going to pause here for a second and really emphasize this symbol. Guys, you're going to be seeing this symbol a lot. You're going to be seeing this symbol in Unit 5 when we talk about congruent triangles. You're going to see it again in Unit 11 when we talk about congruent solids, okay? So congruent basically means the same, like the exact same, but maybe just like in a different place, okay? It's got an equal sign with a single squiggle up above, all right? Now, for my favorite part, when I have segments, all right, there's a very simple rule that I can use in order to figure out how long they are, especially when they're kind of like mashed up together and I have like this weird problem. And this is the rule that I would like you to remember. So I know there it says, if A, B, and C are collinear points and B is between A and C. So there's a formal way to do this, and then there's my way. So the formal way is as follows. Okay, you guys notice how I have a segment here and a segment here, and together they make a whole segment? So the geometric equation, I want you guys to write this down just to have it. would be that segment AB plus segment BC equals, what's the whole thing? Segment AC, right? Now, that's a lot of mumbo jumbo. My personal preference is as follows. We can say that small, meaning this little one right here, plus small, meaning this one right here, BC, equals big. So if you have a highlighter, maybe highlight that, okay? Maybe use some kind of other gel pen or something, or you can just roll your eyes at me. I'll never know anyway, right? But guys, if you can remember that small plus small equals big. If you take two small segments and you put them together, you get a big segment. That will make your lives pretty darn easy. Okay, now with that being said, let's take a look at a few examples of what this could look like on a unit test or on a homework assignment, okay? And for that, we're gonna take a look first at example number, example number 2, okay? So let me actually draw this out, but for reference, we are looking at example number 2. And here's my diagram, all right, PQR. Okay, so they tell me here that QR is 17. So you know what I'm gonna do? I'm actually gonna write that information in. I'm gonna put that information right there on the diagram. It's 17 units long. Then they told me, what am I saying? Then they told me that PR was 21. Okay, so that's actually the whole thing, so let me just draw something like this. Okay, so let me ask this, guys. If I've already used up 17 units, and the whole thing is 21, what's left for this piece right here? So you can do this either intuitively, some of you guys may be able to see very easily the answer is, in fact, 4, right? But there's also a way to do this with algebra. In Algebra 1, if I didn't know something, what could I use to represent it? I would use something known as a variable, and my favorite variable ever is x. Okay, so if I call this x right here, okay, and I know that these two are both smalls, my equation tells me that if I take a small plus a small, I get a big. So take a look at this. X plus 17 equals 21. And look what we've done, guys. We've taken a horrible, nasty, no good geometry problem. No, it wasn't so nasty. But anyway, we took a geometry problem and we turned it into a one-step equation from 7th grade. So I would use inverse operations here, subtract 17 from both sides, and lo and behold, that piece right there is 4 units. Okay? Now, on a test though, if this were to be assessed, it would most likely be as an algebra question. That was kind of like a baby question, right? I gotta be honest with you guys. Now let's see how it would actually look on a test. So we're gonna take a look now at example number 3. Okay? So number 3, they give me a slightly different diagram. So let me just draw this out here. What does it say? EFG. There we go. I can't spell. EFG. And 8x minus 17 and 5x minus 3. Got it. And the whole thing is 71. All right. By the way, this is number 3. Okay. Oh my God, I think I'm blocking. I am so sorry. Can you guys see that? Yes, of course, I can do that. Okay. So, notice that this problem is exactly the same as the previous one, just with a little bit more in the way of algebra. First, let's identify our two smalls. Our two smalls are from here to here, so the 8x minus 17 and the 5x minus 3. When I put them together, right, through addition, what are they going to equal? Like, how long is the whole thing? 71. So, because my poor marker is kind of dying on me right now, they seem to do that an awful lot these days, let's write ourselves an equation, okay? So 8x minus 17 plus 5x minus 3 equals 71. Let's stop for a moment here. How the heck did I do that? I took two smalls, I added them together, and I got a big, right? Now, one thing I'm going to caution you guys about. This is very important from Algebra 1. Do you guys notice how I have x's on the same side and I have constants on the same side? That means I'm not doing inverse operations first. Before I can do inverse operations, I have to combine like terms. So if I have 8x and 5x, what is 8x and 5x together? They make 13x. Similarly, I lost 17 and I lost 3 more. How many did I lose in total? I lost 20. Oh my gosh, isn't that a much nicer equation now? I certainly think so. So, how do I get rid of a minus 20? I would add 20 to both sides, right? Okay, so I get 13x equals 91. Divide both sides through by 13. And don't quote me on this, I think 13 actually goes into 91 7 times. Please don't use a calculator, but I'm pretty sure it does, right? So in this case, we are done. So look at that. The geometry was literally the first step. Everything else from there is just Algebra 1. So if you guys can do the algebra, it's going to be pretty darn easy for you, okay? Now, the one thing I do want to caution you guys about is the substitution, okay? So I'm not actually going to draw the example, but I do want to work out the equation for you for question number 4, all right? Because this is a tricky thing they love to do. So without drawing it for you, just take a look at what you see on your paper. The 9x plus 2 and the 5 are your smalls, and the 14x minus 8 that they tell you in the problem is your big. How do I know that? Because the whole segment is TV. So, and I apologize if this is a little bit fast, guys. I'd be more than happy to go over with you individually if need be. But 9x plus 2 plus 5 equals 14x minus 8. So again, 9x plus 2 is a small. The 5 was one of your smalls, and the 14x minus 8 is the whole thing. So that's why it's alone on the other side. First, combine like terms. So I get 9x plus 7 equals 14x minus 8. With the algebra here, we got to make a choice. Would you guys rather get your x's on the left or the right? Well, I'm going to say I prefer to get them on the right, because if I try to get them over here, I would end up with a negative in front of the x. And I don't know about you, I hate negative numbers. So what I'm going to do is I'm going to minus 9x from both sides. So I get 7 equals 5x minus 8. So I got my x's on the right. Where do I have to move this now? To the other side by adding 8 to both sides. So I get 15 equals 5x, divide both sides by 5, and I get x equals 3. Uh-oh. Why would I get this wrong? Why? But after all, oh my gosh, you can't even see that. I am so sorry. Hold on. Ah. Okay, after all my hard work, why would I get that wrong? Anybody? The question said find TU. So in this particular problem, TU was actually given by 9x plus 2. So what I would actually have to do is I'd have to take that 3 and substitute, right? Once again, because they didn't actually ask me for x in this particular problem, but they asked me for TU, I would actually have to go back and substitute in order to get my correct answer. Oops, sorry, I hope I didn't block that work for you. Sorry about that. So, in a nutshell, a line segment is a portion of a line that lies between two endpoints. Okay, I know that wasn't really in your packet, but that is a possible EOC question, so you've been warned. Big idea number 2. When dealing with line segments, small plus small equals big. Let me try that one more time. When dealing with line segments, small plus small equals big.